Good evening all. We will wait another couple of minutes so till everyone joins. If you have any queries, maybe we can get started with the session from the last couple of weeks. In the meantime, let's have just a recap of what we have been covered in the last 3 weeks. So basically, the first week we started out with saying that most of these models will actually need to be implemented on computer. So the first step would be to actually quantify whatever you will be requiring, then get some numbers for each of the things that are of your interest, and that's when we started discussing about what are vectors and matrices. So basically, something you have a data which is a quantified way where you have some numbers, and then we kind of discussed what are the ways to store them, matrices, and that's where the linear algebra comes, and then different ways. We also discussed on what are eigenvalues and the other decompositions and why are they useful. We have solved some problems where we have ultimately we would be coming up with some input and some output. So you have some input that goes over some operation, and then you will get some output. And we told that if your input can be represented as some vector x or some matrix x, and your output is denoted by some vector or say matrix y, then this operation that transforms your input to output can be represented with a matrix multiplication operation. So you have ax equal to y, and our objective would be could be like if you know a and x given the input, you can determine the output. In case of there are other classifications of algorithms, so you might have gone through the videos. Say you might be using say supervised classification where you initially know x and y, and your objective will be to identify what is the value of that particular a that transformation that will convert x to y. And once you know a, you can use it on some other new variables of x which were not trained before, and then with that new values of x you can get the new values of y. So with that objective in mind, we started discussing with this. So we also discussed on how to solve these equations, as in we didn't actually solve it ourselves, but we know that you can solve these equations. And then we also discussed some basic concepts of what are vector norms. So why do we need a norm of a vector? So we discussed on several norms, L1, L2, L infinite, Frobenius norm, and all of them. So basically these are to essentially quantify your vector with one single number. It could be L1 is your these are something that we have discussed previously. And then we also discussed on that compares your first week of lectures, and in the second week we thought that x and y are like deterministic, but in real world scenarios most of the times you would not be knowing most of these variables, and you consider them as random. So there was one of the student who actually answered in the last session, so why do we consider them, why did we do probability? So I could just measure x and then measure y, and from then I could get it directly. So why do I have to consider it as a random? So when do you have to consider it as a random, and when do you have to just forego this random? Like when do we have to use probability, and when should we not? For the present context, our idea is to essentially quantifying your uncertainty. How do we quantify the uncertainty? Say you take an example of weather forecast. So maybe that would be an easier example. So if you take a weather forecast, so if you see on your mobile app, it just gives you that, say you have 80% chance of precipitation. So what does that mean? So what does this number mean? 80% chance of precipitation. If you go with the frequency, like the original definition of probability is your sample space out of your desired outcomes divided by your total sample space. So using this definition, can you explain this particular statement, that if you open an app and it says that there is 80% chance of precipitation, what does that mean? How do I have to interpret that? Maybe one way of doing it is, say over the last 10 years of whatever data I have collected, on this particular day, say on this particular date, say 10th Feb, over the last 10 years, 8 years we had a rain. Is this the way to interpret, or there is any other way to interpret this? Or maybe you just not sure. We have done like around, say, 10 problems in the last week on probability. So why are we emphasizing on probability? Even your assignment questions, there are a lot of questions on probability. The entire week is dedicated to probability. So there is some essence for it in this particular context. So I just want to emphasize that in most of the scenarios, you do not know exactly what it is going to be. In the sense, say suppose the precipitation will depend on, say, factor 1, factor 2, like say that it depends on temperature. It depends on temperature, say it depends on the clouds, it depends on the wind velocity and so on. So there are 100 different factors that could affect, and not all of these factors could still give you reasonably accurate that it will rain. Because some of these parameters, in some scenarios they were able to give a reasonable estimation, but in other scenarios there are exceptions even to the rules that you have generated. So you cannot determine with 100% accuracy that rain is going to happen with this particular temperature, velocity and clouds. To account for that, or to quantify that, we give only the probabilities. So when you want to actually make a decision, you need to make out of this. So only with this 80% chance of precipitation, say suppose do you want to carry an umbrella outside or not? If that is your objective, that is something that cannot be answered using a model that only predicts the probability of rain. So that is something that I want to differentiate here. So we can say in 100% air, we can say in 100% air, 80% has the chance to get precipitated. In a 100 gram air might lead to 80 gram precipitation. By precipitation I mean rainfall. So that is more of second week's lectures, and then once the probability is done, the next part that that was discussed mostly here is how do you actually represent it in computers. So this week starts with overflow and underflow kind of concepts, so we will go through that. So I hope that you have already gone through the week 3 lectures, now that week 4 is also uploaded. So we will just quickly go through the problems, and as and when it is necessary we will take those concepts. We will get started. I think we have yeah, people have joined, like it's kind of stagnated. So we'll get started with the assignment. So first question says that you have some variables that you want to store using a uint4. Uint4 is basically an unsigned 4-bit integer type, data type, and with that in mind, we need to answer the following questions. This should be fairly straightforward if you have gone through the video. If not, let me know, then we will discuss this. So what is the range for the set data type? For this particular data type, what is the range of integers that you can represent? So you have a uint4 type data type. So it has 4 bits. So I can store up to 4 bits. So what is the range of the numbers that I could store using this data type? What is the minimum and maximum? This is binary, like you will be storing finally in some binary format. So what is the minimum value if it is an unsigned integer? So 0 to 2 power 4 minus 1. So the minimum value is this, which will give you around 0, and maximum is when you have all ones, which will give you 2 power 4 minus 1, that is 15. So the range is 0 to 15. Now if I have these x1 and x2, x3 are 3 variables that are storing these particular numbers, then what will be the values of this? So now that you already know the concepts of underflow and overflow, ensure that things are properly done. Say not using hand calculation, but then you are using a finite precision arithmetic. So what would be the values of this? So if it were normal arithmetic, it would be just 14 plus 2 plus 1, which will give you a 17. But then, like he said, our current data type range is just 0 to 15. So you cannot store 17 in that. So what would the value of this be? Let me know if something is not clear in the question. 1. So how did he get 1? So when you add x1 and x2, which is 14 plus 2, that will be 16, but 16 cannot be stored. So once 16 cannot be stored, it will just cycle back. So instead of 16, you will go back to 0. So this will become 0 plus 1, it will be 1. So what about the second one? Zero. Why do you think it is 0? Okay, 0 or 15? Can it be not 15? So x1 plus x2 is still the same. So 14 plus 2, 16 will become 0. Now I am saying 0 minus 1. So this should cycle back. So you will be actually getting the last value. Okay, well, how about the last one? Here 14 minus 1 is 13, 13 plus 2 is 15. So this is straightforward, so you'll just get 15. Okay, now out of these 3 cases, where did overflow occur and where did underflow occur? That is again straightforward. So in the first case it is an overflow. In the second case you have both overflow and underflow. In the last case you just have nothing. It's like it just worked out fine. So the first question is straightforward. yeah, like second question requires a little bit of discussion. So if you already gone through the video, so it should be straightforward. So you have the following set of equations. I want to write it in the matrix form. So how would I write it? This is the first part is straightforward. So you just have two equations, and then you can write it as in the matrix of form Ax equal to B. So the equations are x plus 2y equal to 4. And then my second equation is 2x plus 3y equal to 7. If you want to write it as in the matrix form, so this is my A, this is my X, and this is my B. So I have my matrices. This is straightforward. Now maybe I will just to have a little bit of calculation. Can you calculate A inverse for this? Are we doing assignment 3? Assignment 3, yes, but not the one that you have in your course. Do you have any doubts in the course? No. Okay. So the session is mainly to help you in solving the assignments or helping you solve the assignments, but these questions will be different from the questions that you will see in assignments. Since they are graded, I cannot discuss them directly in the live session. Yeah, so he has calculated A inverse. This is my A. So is this right? Can anyone confirm? Yes. Okay. If I just multiply this and this, it doesn't seem right. So is it a minus 2 or plus 2? Because if I multiply these two, I think it's just not summing up to I, right? A times A inverse. Isn't it something like this? Minus minus 1, so we have minus plus plus minus. It should be something like this, right? Yeah, it should be something like this. Minus 3, 2, 2 and minus 1. This gives. So now that I know A inverse, the next part is essentially asks you to calculate the infinite norm of a matrix. So I'm not sure if you are familiar with it. So how do you calculate the infinite norm of a matrix? So this is my A matrix. So what is the infinite norm of A matrix? What is the norm of a matrix first of all? So norm of a vector is straightforward. So if I have norm of x, say infinity, it is max of x. Max of you take all the elements and whichever is the maximum one, you just take that. So that is straightforward. So how do you, what is the L infinite norm of a matrix? So do I have to take the maximum of all the elements in it?
Yes.
Okay, it's not actually that way. So the norm of a matrix is defined slightly different. So if you have a matrix like this, norm is basically the maximum of sum of the columns. Like if it is infinite norm, you have to take summation of the columns. So in this case, if you sum up the say okay, we have to start with A. So if you have A matrix, you have to take the sum of the columns. So this gives you 3 and this gives you 5. And once you take the sum of the columns, out of this whichever is the maximum one will be your norm. That is an infinite norm. So if you want to take L1 norm of a matrix, then instead of column sum you would be taking row sum. So you take sum here 3 and 5, and whichever is the maximum will be your L. So if you take rows, it will be L1 norm of a matrix, and if you take columns, that is going to be an infinite norm of a matrix. Is that clear? It's so suitable for building a basic foundation for research in pins with a mathematical background. It's an interpretation of infinite norm of a matrix. Okay, there are two questions. So research in pins, so what do you expect by mean so if you want to just get started with it, then it should be sufficient. But where do you want to use pins for? So you're from mechanical background, or is it in a different? Yeah, I understand that it is for solving a PDE. So you're already familiar with neural networks and optimization. Then you should get started with it fairly easily, right? If you're already familiar with neural networks and optimization, then pins are straightforward. They are just an implement, like. So what is the challenge you're facing with that? Okay, come to the next question. Is there an interpretation of infinity norm of a matrix? So it's like your vector itself, but then the difference between a vector and a matrix is, as we said, matrix can be treated as an operator. In all the cases, matrix is just an operator. So when you define the norm as we said is to get a metric out of a particular vector. So but when you want to have a single number that will denote an operator, you need to associate it with some operation. So this norm is treated slightly differently. So norm of a matrix is usually defined like only in association with some operation. So you define another vex x, something like this. So out of all the possible operations that you can take, which of the operations will have the will have more impact on it? So it's like if you have a rotation matrix or say any A matrix for this, each column can be treated as a different vector, right? Say if you consider a rotation matrix, you can say like each one of them corresponds to 3 different axes, x, y and z axis. So you want to see which one of them has a maximum impact. That's what you want to see in case of a vector. If you just have vector, you will just get the maximum component of, like if you have x, y, z components, you will just get the maximum component out of these 3. But when you want to do it for an operator, you need to see along 3 different axes and then see which of these axes has maximum impact, instead of taking sum of all the elements, because you just can't take sum of all the elements, because you are adding elements from different 3 different independent vectors, which doesn't make much of a sense. You need to treat them separately, right? So if you have a vector a bar and b bar with 3 components, adding them is like adding only the x components, adding only the y, or adding only the z, and then you come up with a new vector and then define on that new vector, instead of doing only on instead of doing just maximum of all of them. Does that answer your question? Or as we see, we will see another what are implications we have with this infinity norm here right now in this example itself, instead of going for another one. So now we have infinity norm for A. So what is infinite norm for A inverse? A inverse is this. So it should be straightforward. So you have 5 and 3. So the maximum is 5. So this is your A inverse. So the course also in like lectures also discuss about something called like condition number of a matrix. So maybe if one of you can. So what is the condition number? Like what is this condition number here? That I am saying that I am defining in this particular way. So what will I use this for? So like as we started out initially, so if you have a set of equations that you want to solve, Ax equal to b is a ratio, okay, condition number is a ratio of the largest singular value, okay, maybe you will say the ratio of largest singular value to that of the smallest one, okay, you can define it that way. So okay, but okay, directly went to singular value instead of eigenvalue, that's actually good enough. So why do I have to know this number? So why do I have to know the condition number? This is a way, so there is one definition. So the condition number, if I am just denoting with k of a, so is defined as the ratio of the largest singular value to measure the sensitivity of a function. Okay, what functions do we have here? Error function. Okay, where did I get error function directly from? So like, can you put this in a proper context of whatever we are discussing or whatever is being taught in the course? Maybe you are giving it in a slightly different context, but in the present context, in machine learning context, or say in the linear algebra context, what is error function? Error in the input. So basically what you are trying to say, okay, as I understand, so to measure the sensitivity of error with respect to input. So if my input is not correct, so if I want to solve the system of equation Ax equal to b, but then I do not know for sure that the A and B that I have are accurate enough, so there are some errors in that, or then how will it actually impact my result? Say if b is replaced with b prime, then how will x change? So if b is replaced to b prime, then x will change to x prime. So how sensitive is this change? So that is what we were trying to do using this. So in here in this particular example, so I am saying I am defining condition number in this way. So okay, now that you have given the definition, so should I need the value to be greater than 1 or less than 1, equal to 1, or what is it that you want from it? Or it can take any value. So what is the number that I want? So I want it to be least sensitive. So even if there are some errors in B or A is, like as we said, A is an operation. So A is something that you get once you train your model. X is your input, B is your output. So even if there are, say when you are training your model, so the data you collected with your input and output. So if you take this is my input. Say this I can call as a model, and this is my output. So when training the data, if there are some errors in A, B, how would that actually propagate, and then how will that affect my model? And if there are any inputs, if there are any errors in the input, how do that propagate when I am predicting the outputs? So these are something that we want to analyze. So then we came up with a metric that will give the, say, called condition number in this particular way. So what is the value at which I am sure that the model is not working, or say when the model is good enough? So what is the value that I expect from this? I want it to be close to 1, but not too high. If the value is too high, it means it is too sensitive and the errors will be too high. So in this particular case, the condition number is 5 times 5, that is 25, which is like large enough, which is much greater than 1. So the solution might not be, or the problem as we formulated in this particular way is highly sensitive, and then even if there are minute errors here, in say instead of 4.7, if you have say 3.99 and say 7.01, then maybe your xy might be different. There are some ways to deal with this, which are by default implemented in your, say, if you implement using MATLAB or something, so we don't have to worry that much. But then when you're implementing, if you see unexpected things that are coming up, MATLAB will actually give you a warning before actually solving the system. It will tell you that it is an in-condition matrix. That is not going to be an issue. The same appears even with NumPy and stuff. So you don't have to worry much about it when you want. Only if you want to actually implement your own code, that is when you have to take care of these things. So in this particular case, the value is greater than 1. So we are saying it is an ill-conditioned one. Okay, this is a very straightforward problem. So we have some function f of xy. So what are the critical points? So this should be straight. Okay, I have a method. Okay, if it is with respect to programming, then maybe I suggest you use some packages that already do the programming for you. Like for pin, there are like I think you are using Python, right? Or if you are into MATLAB, I'm not sure about MATLAB, but if you are using Python, there are packages that already implement the code. All you have to worry about is your formulating problem formulation. That's it. So you can use those packages instead of writing your own code. If you are using Python, I'm not sure about MATLAB. How to calculate actual output error bound from the condition number. So for an analytical case, it is slightly different. For your question, how to calculate actual output error bound from the condition number. So say suppose even if you were to calculate it, the problem here would be slightly different. So I think you are asking from a linear algebra perspective and not from the finite precision thing. So if it is from a linear algebra perspective, so yeah, you can define condition number in the same way, right? So basically your condition number is how much your output changed with respect to your input. So I can put it as norm of delta b, or I'm just writing delta b as your error, by norm of delta x. So this is your change in your input with respect to change in your output. This is something I am calling as my condition number. So from this you will be able to estimate only from the norm, not with respect to individual vectors, but as a whole how much change in your output can be expected for a given change in input. But to be say calculating this condition number itself is very challenging. You cannot do it only for few matrices like the formula I presented here is when you are able to calculate A inverse. But calculating A inverse is itself a problem. It is in itself is a different problem. If you do not have square matrix, you will not be able to calculate this also. So determining it in this way is very difficult. So you calculate condition number and from there you multiply this and getting this is something that is not that practical always. Instead you perturb your matrix and see what the results are. That would be much easier way to implement it instead of the way I suggested here. Even if you want to do with the largest singular by smallest singular value, this is just an approximation. This is still going to be an approximation for it. It will tell you whether it is conditional or not, but from there to actually get the error bound is it won't give you the exact ones. You can only get up to a limit. Having said that, so why do you require that? So what is your objective in knowing the error bound? Why do you want to know the output error bound? To see how accurate your model is or something else? Okay, if it is a mathematical exercise, okay, it's a different thing. If it is a mathematical, that should be fine. But if you want to actually see the performance of your model, say you already trained a model in the sense, since we haven't actually dealt with the actual training and stuff, I'm just giving a simple example. So you know some x, you know some y. Now you found out some a that will give you a times x is equal to y. So you found out some a. Now using this model, you have some new input x prime. So you apply this transformation, you get y prime as your output. So if you want to know what is the error bound for this y prime, so say if you want to know how accurate your model is, you will not be able to say that, because getting condition number is slightly it's more complicated. So what do you do in such scenarios is you actually you actually test it out, and this uncertainty whatever you quantify here is you perturb your inputs. So for different inputs, so instead of x you actually add the error yourself and then see what the outputs will be, and from there you will quantify it. That should be clear. I mean, it's fairly straightforward. Instead of calculating inverse, you just perturb the matrix, perturb the input, and then see what the outputs are, and from there you quantify it. before actually going to third question, so maybe we should, what are the packages like TensorFlow and PyTorch? Yeah, they are the native packages for any like I was actually referring to as so say like you have I hope you are already familiar with Python. So like TensorFlow and PyTorch, there are separate you can find codes in GitHub. They are open source anyway, where people have already implemented pins using, I think it was done using Keras. So since Keras is already part of TensorFlow, so I think it is with TensorFlow, but I'm not sure. Maybe people would have done it with PyTorch also, but there are separate packages in GitHub that you can find that have implemented pins. Maybe you can just search now, you will find that. This should be a fairly straightforward problem, so I hope you will be able to solve. Maybe I'll wait for 5 minutes and then you can give me the answers. So it's just a function that I want to find critical points. So what are critical points? But the GitHub code is not working well in every case. Every case, yeah, I mean you might have to tweak the code a little to suit your needs, but everything else should have been fine. Like which part you are facing problem? So is in the problem setup or the optimization part? Like basically when you are actually trying to solve it. The problem setting itself. Okay, but there are other alternatives also, right? It's not one code, like people would have done so many other codes as well. DeepXD, okay. So maybe we will take that up maybe in one of the sessions. Not now immediately, after neural networks are introduced in the course. Maybe we'll take some simple examples and then we'll see. So in every case, in the sense, is it working for simple cases and then as the problem gets complicated, it's not able to work, right? Is that what you're saying? Or maybe you can unmute yourself so that, okay, as the problem gets complicated, it's getting tougher. Tougher, like is it getting tougher, like is it not able to solve the problem or the results are not good? Maybe we'll discuss this after some time. So we'll close this problem and then we'll discuss. Maybe you can unmute yourself so that it will be much faster. Yeah, so what are the critical points? So getting critical points is straightforward. So okay, before actually going anywhere, so let us always ask the question first. So why are we doing this again? So I have some function here. Okay, it is some random function, say for suppose. So I want to find the critical points, extreme points and saddle points and different points. So what are all these points are? So why are these points of special interest to me? So what is so special about critical points or extremum values? Why do I worry about them so much? Okay, now that you mentioned in the optimization, so what are we trying to do in an optimization problem is just to put simply, so if you have n equations and n plus m unknowns, say both are positive integers. Basically you have more unknowns than your equations, so you cannot use like methods like this to actually get a solution directly. So you can have even inequalities, which is something that we will discuss in the next problem. But for now, the point here I want to make is, when you have more unknowns than your equations, or basically to say you have lot of variables, but then the constraints are less than the number of variables. In such scenarios, you will not be able to solve them using the linear algebra, the one that we discussed before. Like if you cannot formulate it as system of equations and then be able to solve, because if you were to do it that way, so your A matrix will be, your X will be of size n plus m, but then your A will only have this total number of equations will only be n equations. So this will be n plus m, and A will be n by n plus m. So this is not going to be a square matrix, and then you cannot do inverse of it. If it is not a square matrix, you cannot do inverse of it, and then you will not be able to solve anything. So what does the optimization do? Instead of solving the equation, it formulates the problem in a slightly different way. So instead of trying to solve equations and get an exact value, we put different objectives and try to minimize or maximize whatever is our requirement, and then see and take those particular values as our solution. So extremums are, as I said, like in the search space or maybe landscape or your search space, once you identify these critical points, these are the points where your maximum and minimum will be there. So if your objective is properly formulated, then this objective function will be of any use to you. So the steps that we do not discuss in even in the assignments or something are, what are these objective functions that you should be considering. That is something that we will not be discussing. We are only bothered about how to solve them if the function is given. But the problem that you would be facing when you actually solve it, try to make a problem for yourself, is getting the actual how to actually get this objective function. That is something that you will be facing when you actually want to develop your own models. Okay, for this problem, the critical points are straightforward. So you just take del f del x equal to 0. This should give you critical points. So what are the points you are getting? Minus 2 plus 8.6, so this should be fine. Minus 1 are your critical points, and then from there you can determine the extremum values. So this should be straightforward. So do we have any saddle points here? It's okay. What are saddle points? So you have either a min, max, or you have something called saddle point. So what are saddle points? Like I said, like is there any use for saddle points, like any application where saddle points are important for us compared to minimum or maximum? No. So our objective should always be, it's like when you formulate your problem, you should ensure that the problem that you formulated is of certain type that will enable you to get minimum or maximum, because all these algorithms will try to find minimum or maximum. So if you have saddle points, then what happens is something that you won't actually reach any conclusion, or you don't get actually any solution. I'm not sure if how many of you are familiar with unconstrained optimization, because okay, the next one is an unconstrained, the next one is a constrained optimization with inequality constraints. So maybe we'll wait 10 or 5 minutes. So can you solve this problem yourself? I just want to know how you are going to solve constraint problems. There are several ways to approach this, so maybe you can say which one you are trying to do. The ones who are already familiar with machine learning, how do you solve this? So one of you has mentioned that you are already familiar with machine learning problems. So if you have some constraints, say in pins that you mentioned, even in pins you have constraints, right? So when you train your pin, how do you train your pin? So to others who are not familiar with pins, pins are essentially physics informed neural networks. So they are a specific class of machine learning problems that are used to solve the partial differential equations. So the problem there is to solve a given partial differential equation. So if you have some equation, say if you have equation something like this, and then if your objective is to find u of x comma t, pins is a way where you actually approximate this particular function with a neural network, and then you try to solve this differential equation. So how do you solve this differential equation? By you actually pose this as an optimization problem and then solve it. But then when you are posing it as an optimization problem, you are trying to minimize something. What is it that you are trying to minimize? Is essentially with respect to this constraint, that whatever model you propose should actually minimize this particular quantity, or minimize this, or satisfy this particular constraint, to put it slightly different. So ideally you would be having several different constraints. Say if you are solving, if you are from fluids or from mechanical who are doing CFD, for them the objectives would be to minimize your mass balance. So basically mass conservation, energy conservation, and momentum conservation. These are the several things that they have to have. So those will be the constraints. In every domain will have their own constraints. So how do you solve this problem? This is something that you will frequently encounter. So how do you solve the constraint optimization problems? Lagrange multiplier. So originally Lagrange multipliers are for equality constraints, right? Yeah, you can solve inequality constraints as well, but it will get a little tougher. Yeah, but you can still use Lagrange multipliers. This particular problem is simple enough that you don't actually need to use Lagrange multiplier. You can directly solve with graph itself. Yeah, now that you have mentioned Lagrange multiplier, so you might already be aware of KKT conditions, Kuhn-Tucker conditions. So to those of you who are not familiar with that, you don't have to worry about it. We will not actually be requiring that in this particular course, but that is one way of doing it. Are there any other ways? Newton-Raphson. Okay, how do you use Newton-Raphson? Newton-Raphson method is actually useful to solve a set of nonlinear equations. So how do you put constraints into your equation? So basically Newton-Raphson will be like, if you have some function f of x equal to 0, and if you want to find this particular x star that will solve this particular, like x star is the root of that particular function, then you use Newton-Raphson. So in case of an optimization, if you have f of x as your function, you take derivative of it, so that will be g prime of, or say f prime of x. You assume this as g of x, and now this g of x will be input to your Newton-Raphson, which will give you that particular x where f prime equal to 0, so that will give you your extremum. That will help you to find your extremum. That is clear, but how do you incorporate constraints into this? Maybe to give you an example, say suppose suppose you are trying to solve a fluid problem. So you have some data already with you, so you know some inputs, some boundary conditions, and then you have some output. So what you want to do is you already have the data for this input, what is the output. So say suppose x1 is your input, and for that you have an output y1. Similarly x2 you have an output y2, and so on. So what you are trying to do now is you try to minimize the error of this y is what you have the original data, and then you have some model. The model has predicted something. So let's say it has predicted y1, y2, p and so on. So what you will be trying to do is minimize the error between these two, right? So if your objective function has been just this, y1p minus y1 square will come to y square, and why we are doing this maybe in the next week. Yeah, next week linear regression starts, so maybe in the next week, in the week 4, to those of you who have already gone through week 4, you should have understood this clearly. If not, just for now take it as I say, that if you do this, like if you formulate your problem in this way and try to minimize this, you will be able to do that. So now I also have some additional constraints that say that there are some conservation principles that also have to be taken into account. It's like there are some other relations also. I can't take any y, but there are some relations that say y equal to something like so each y, whatever yi is there, some f of yi comma xi is equal to or less than or equal to 0 or something. I have some other constraints like this. So how do I take them into account? In physical scenario, it might be like once you collected the data for a given velocity, what will be my outputs, and then I predict something. I'll minimize that error, as well as in addition to that, I will also have to minimize whatever is the total mass conservation error, like basically mass imbalance terms. So if I want to add something like that, how will I add it here? Using Lagrange multiplier, it will get a little more complicated. Analytically, it will be better, but when you want to implement it, say for practical purposes, it will get a little more complicated. So any one of you already familiar with NSGA or basically genetic algorithm or any of the multi-objective optimization problems? Any evolution method, differential particle swarm optimization, or any of the other optimization methods? Okay, then it is clear. Okay, if you are not familiar with it, that is a slightly different way of modeling it. So what you do here is you take each of your constraints and then you add them to your objective function itself. So if f1 is my objective function and g1 is my constraint, what I do is I have some penalty parameter and then add this constraint also to my objective function. So what my optimization algorithm tries to do is minimize both f and g, like it tries to minimize this new function, but in order to minimize this new function, ideally this g1, if your g1 is always positive, then this particular thing can go at max to 0. So it will try to satisfy that particular case. So if you have equality constraints, say suppose if g1 is equal to 0 is something that you want to satisfy, then you pose your optimization problem in such a way that f is actually f1 plus lambda times g1 or lambda times g1 square. So when you try to minimize this particular function, it has to f1 has to be minimum, at the same time g1 also should be minimized. Only then your overall function will attain a minimum value. Is that clear? Instead of doing differentiation, it is very similar to your Lagrange multiplier. The idea is the same. Even in Lagrange multipliers, you would be doing the same. You would actually add, so when you have n equations and n plus m unknowns, you add m more parameters. So you have lambda 1, lambda 2, lambda 3 for each equality, and then you do differentiation with them, and then from there you get a go ahead. Yeah, like your Lagrange multiplier. The difference here is if you are solving using Lagrange multipliers, you actually try to get the values of those Lagrange multiplier. So Lagrange multiplier has a physical significance to it. That essentially determines how sensitive is your particular problem with respect to your particular constraint. In here, instead of actually solving lambda, you actually specify a given value for lambda beforehand itself. So you tell what the lambda, so you fix the value of lambda before itself. That's the only difference. Otherwise, everything else is similar. So that way you will not be actually solving for lambda, so that will actually reduce your computational cost. And then there are other advantages as well, which say in most scenarios you will have so many constraints in place. In that scenario, taking differentiation is actually quite expensive. So instead of it might be required that you will be using methods which do not require differentiation, which is something that we will not be using in this particular course, but you might be requiring them. Methods which do not require any differentiation to do optimization. So evolutionary methods are one such methods that will help you there, where you don't have to do differentiation to actually get the extremum values. Coming to this particular problem, so we have an objective function y minus x, and we have the constraints as so and so, and I want to find the minimum value of this particular function. So I'm not taking any of this Lagrange or any other methods right now, because you will not be using them in the course. So I'll just use geometric one, so it will be easy for you to understand what are we trying to do. So if these are my axes, the function is y minus x, and then my minus 1 should be the answer from the graph. Okay, should be less than or equal to 1. So how did that turn out? So you have some, these are my constraints, so this is my domain. So within these boundaries I need to find the solution of this particular equation y minus x. So y minus x is like y equal to x plus c, something like that. So I'll use a different color. So the lines will be, something like this. So this is y minus x equal to 1. So when x is 0, y is minus 1. Okay, this is say some other value, say minus 0.5. So this is y minus x equal to 0, and so on. So basically you can vary this y minus x by varying x and y. These are different lines you get, and your objective is to find the minimum value, and this is obviously your minimum value. So y minus x equal to minus 1 will give you the minimum value. So this is your domain of interest. It's a very simple problem, so I was able to draw this, but if you want to actually solve it, then it will take maybe another 20 minutes to actually solve it using Lagrange multipliers. So we'll not go into that. So coming to the last question, I thought we'll spend a little more time on this question. So anyway, we have reached 1 hour, so if you have any queries, then we'll stop for maybe like 5 minutes. If you have any queries, then I'll take them. So you are mentioning on pins or something, so we can see. Maybe you can ask what is there. What exactly is your problem? The challenge you are facing. Or if you have any other queries, then maybe like it's close to 1 hour we started the session, so maybe I think we'll stop for like 5 minutes. So if you have any questions, any other questions from the last 3 weeks or whatever you have seen through the lectures, then we can discuss them. Otherwise we can go to the last question. Yeah, I guess there are no questions. Okay. The last question says like you are sitting in an exam hall, say some student is sitting in an exam hall and he doesn't know answer to a particular question, and that question has 2 options, so you can choose one of the 2. So what is the probability that one of them is right? So you just have 2 options and you do not know what is right or wrong, so each one of them should be equally likely. So the probability of any of the answer, the probability that whatever you choose is right is only 50%. So the first question asks you to populate that table of true positives, true negatives, false positives and false negatives for the options that he chooses. So first is straightforward one. So if you do not know the answer to a question, so if I just first have, we'll go with the formality like how we define. So I define one event A. A can take 2 values, 1 and 0. 1 is if the answer is true, if the answer is false. And similarly I choose another event S that can also take 2 values, 1 or 0. A is like the actual answer, S, I am defining an event of whatever I select. I can either select true or false. Now the first part, what it is asking is, now S can take two values and A can take two values. So all it asks is what are these particular values here. If I want to construct a joint probability distribution, so what these values will be. So if I do not know the answer, all of them should be equally likely. There shouldn't be any difference between what I choose and what I do. So everything is just random enough. So everything will just be 0.25. So there are 4 possibilities in the sample space. So all of them will have equal probability. So this should sum up to 1. So first part is straightforward. Now comes the second part, where I actually want you to solve yourself. Now that that particular student has seen one of his friends' answer, that particular another person has actually put true for that particular question. Based on his previous knowledge, he knows that the probability of his answers, friend's answer being correct is 0.6 for true and 0.8 for false respectively. Using this new information, how can he decide whether to, okay, after seeing his friend's answer, will he decide to choose true or false? So previously, if he has not seen his friend's answer, everything is equally probable. Now that he has seen that his friend has actually marked true for that particular question, so how will these probabilities change? How will these, like initially everything is 0.25, so how will these change? Okay, first I should ask the question, will this change at all or not, is something that the students has to take into account. But say suppose it will change, so how will these values be now? Is the question clear first? I think the question is clear. So how do you go about solving this? So are there any suggestions? How do I go about? So what are these 0.6 and 0.8? So whatever you know from the previous knowledge is basically that whenever that particular one of the friends has said true, it was right 60% of the time, and whenever he said false, it was right 80% of the time. So now if I define a new event, say F for the friend, so he can actually mark again two things. He can either mark true or false. What I am saying is, whenever the friend said 1, the actual answer is 1 with a probability of 0.6, and whenever he said 0, the probability that the actual answer is 0 is given as 0.8. So this is what is given. the question that is being asked now is, if you already know that f equal to 1, what is the probability that you will actually select f1? Can you solve this? Maybe if I formulate it in this particular way, will you be able to solve this? Just to bring things into context, so you can think of it in this way, where the actual is something that you have in your training data, in your original data, you have some distribution for thing. S is something you can call it as a strategy that you are implementing, or that is a model that you are implementing. F is something that you have observed recently after you have the model in your mind. So you have seen some data, and from observing the data, you created a model of your own. And once you create the model, now we have seen a new observation. Now, based on this new observation, how is your model going to change, or is it going to change or not? That is something that I want to highlight through this particular problem. So how are you going to implement that? Is the question clear? Yeah, question is clear. Okay, so maybe if I wait for a few minutes, you will be able to answer it. So how will I calculate this particular value? You can try it for maybe 2 minutes, and then if not, then we'll discuss it. This is something that you will face in something called, in most of your models you will be facing this. In like you trained actually on some particular data, and then your model is ready, but then when new data comes in, what do you do for your model? So is the new data giving enough information to update your model or not? Okay, so with the information that I have given, you will not be able to actually solve this particular case. Like you will not be able to calculate this. This is something that you have to, it is the same old problem that I have told, that you have limited number of equations, but then you have a lot of unknowns. So this has to be formulated as an optimization problem and then solved with some objective in mind. So since I cannot solve it directly, now I have to pose this as an optimization problem. So what should be my objective? I can have different objectives. So in this particular scenario, when I am writing an exam, my objective should be to maximize my score. So if I want to maximize my score, what it is basically, when will my score be maximized? So I have 4 cases, each of them here. So now I have 4 different scenarios, and my objective is to maximize my score. So what I can do, I am saying like all of them are equally likely, which is something I will come maybe once regularization starts. But for now, we are assuming that there are no coefficients. But one thing is clear, that whenever I selected 1, the answer should be 1. Then it will be helpful to me. So my score will be maximized. And if I consider, if I select 0 and answer is 1, my score will not be maximized. So I put a minus before that. And for the third case, 1 and 0 is also similar. That is something that I do not want. And for the last case, if I select 0, answer should be 0 is something that I want to maximize. So if I formulate this entire thing as my new objective function and then try to maximize this objective function, that should give me some value of this. But in order to do that, I need to have, first thing is I need to actually pose a problem in a slightly different way. So this is something that I do not know. So I'll call this as some variable x, and similarly I do not know the other one. So if he has chosen 0, or maybe I'll, okay, if he has chosen 0, what is the probability that I'll select 1? So I'll call that as y. So with these variables are something that will decide my strategy. So whenever I've seen an answer 1, so what should I do? I will, so what does this mean? So if I've seen that he has marked true, then with the x probability I'll also mark true. With 1 minus x probability I'll mark false. That is what I meant by this. Similarly, if I have seen that he has marked false, with y probability I'll mark it true, and with 1 minus y probability I'll mark it as false. Just okay, I hope this is clear. If not, maybe then okay, we'll put it differently. So just to say, so a can actually take two values. It can either be true or false, and I am saying both of them are equally likely, since I do not know the correct answer at first. And in each of these cases I can choose any of them. So if I start from a, yeah, now in each of these scenarios, that particular friend can actually take two values, 1 and 0. The probability that he'll take 1 when a is actually 1 is 0.6. That he'll take 0 when his a actually is 1 is 0.4. And similarly you can have two values here. So when 0, he can take 1. So this is 0.8 and this is 0.2. And when I have actually seen 1, I can again have two choices. The question is, I do not know this particular probability at which I will choose true. If I know that he has already chosen true, the other one will be 1 minus x. Similarly here. So if I know it is a false, the probability that I will take true, say let us say it is y, the other one will be 1 minus y. Similarly the other two cases. So I'll have 1 0. So if it is 1, the probability I'll choose 1 is x, and this will be 1 minus x. And similarly the last case. If it is 0, the probability that I'll choose 1 is y, and this is 1 minus y. Is this chart clear, or are there any questions in this chart? The variables are not shared, right? X and y are right now shared. No, I am formulating the problem in that way. You do not know the values of x and y. You have to find the x and y. Even now I do not know the values of x and y. Without actually knowing x and y, you will not be able to solve the problem. So to solve the problem, you need to find this. A equal to 0, a equal to 1 are the variables. X and y is same. I actually didn't get your question. So a equal to 0, a equal to, a is a random variable. X here is a probability of this particular event. That if your friend's answer is true, the probability that your answer is also true is what I am calling as x. Yeah, it will be 4 different variables, but then you know the sum of 2 should be 1, right? So if you have seen your friend's answer, you can either have only two options. You can either mark it as x or y, then why to call two different variables? I can just call x and 1 minus x, right? So if you say 4 different variables, out of those 4 there will be some other equations, right? Say 2 of them corresponding to 1. So x plus y equal to 1 and z plus w equal to 1. So I won't be needing 2 extra variables. So I can just write x and 1 minus x.
Am I audible?
Yes.
Sir, actually my doubt was that x and y, I think for a equal to 1 branch we have two variables x and y for the cases, and a equal to 0. Are this x and y the same or are they different? They must be different, I think, because why are the parameters being shared?
Sorry, I didn't get you again.
I mean that a equal to 1, we have to find x in 1 minus x, y in 1 minus 1. But a equal to 0, we have defined the same x and same y. Shouldn't these be different?
Okay. So the x and y I am defining here is basically like given that f equal to 1, what is the probability that I will choose 1? So that is something that I do not know the actual answer beforehand, right? So it shouldn't depend on the actual answer. If it depends on actual answer, I have to know the actual answer in the first place, which I do not know.
Yes, sir.
So that is something that is linked through this 0.2 and 0.8, or basically these other probabilities, that if your friend is marking 1, then the probability that you have an actual answer is something that is marked by this 0.2 or 0.8, whatever is there. That is something that you are getting from your previous history, not for the current stamp. These numbers here are from your previous exam, whatever is there.
Yes, sir.
So yeah. So if you multiply with this, then you get your current probabilities, which will be different in both the cases.
Okay, sir.
Okay. Yeah. So I hope this is clear. So now, okay, with these things in, say now, suppose if I want to have the probability that a equal to 1 given s equal to 1 is essentially probability that both a and s are 1 over the sample space that only s equals to 1. So how will I calculate this probability that s equal to 1? So there are different cases here. So I just need to add the probabilities of all these 4 cases, and then I will get this one. So this should be fairly straightforward. So how do I get the probability of 1? Is by following this particular chain. So if I follow this chain, I'll get s equal to 1. That is one scenario. And then I have this chain, and I also have this chain and this chain. By following these 4 different chains, I'll be able to calculate and all of them are like you just add them up, and then you'll get probability that s equal to 1. So if I just do that, so it will be 0.5 times 0.6x plus 0.4y and then you have 0.2x plus 0.8y this is clear. Now what is the probability that a equal to 1 and s equal to 1? So I want both an a and s to be 1. So I have a equal to 1, s equal to 1, this and this. These 2 branches will give me both a and s equal to 1, the joint distribution. So I need to just add those 2. That will be 0.5 times 0.6x plus 0.4y. Similarly, I can do the other probabilities as well. Maybe you can just quickly tell me. Say if I want to calculate a equal to 0 and s equal to 1, what would that be? Okay. Pardon me here. So here instead of actually writing conditional probability, I should actually be maximizing the joint probability, because I want to maximize my chances of. So if I have this as my original distribution table, what I want to do is I need to increase this particular number. I want to increase this number and this number. So basically when I say true, the probability that the answer is true has to be increased. At the same time, I need to minimize these two. So I can formulate the problem as the probability that this and the last one are maximized, and then the other two are minimized. So I wouldn't actually be requiring to calculate this. This should be sufficient. So okay, what is the second one? Probability that A equal to 0 and S equal to 1. I have to just follow the next part. A equal to 0 and then S equal to 1 is this one part and this two part. So there are these two chains that I have to add. So 0.1x plus 0.1x plus 0.4y. Okay, so it is just 0.5 times 0.2x plus 0.8y. So that should give you 0.1x plus 0.4y. And similarly the other ones. So if I just write quickly, so you have A equal to 0, S equal to 0. So A equal to 0 and S equal to 0 is this particular path and this particular path. That should be .2 times 1 minus x and 0.8 times 1 minus y. And similarly the last case, A equal to 1 and S equal to 0. So if I just put that in the table, so we have so both being 1 is 0.3x plus 0.2y. S equal to 1 and A equal to 0 is 0.1x plus 0.4y. S equal to 0, A equal to 1 is 0.5 minus 3x minus 0.2y, and both being 0. If you just cross check this will be 0.5, 0.5. So just add up to 1. Here. Now that we have all these probabilities, now I have to construct my objective function. So my objective function f of xy is basically I need to maximize these two and minimize these two. So basically I will add up the ones that I want to maximize and subtract the ones that I want to minimize. So just like maximizing function f of x is same as minimizing function minus f of x. So ideally I should be writing some constants here, say lambda 1 times I'll come to what these lambda 1 lambda 2 are. So I'll just add up all this. So these lambda are something that you have to choose depending on your problem. Say for suppose if you consider the case of when COVID tests are being taken, so what do you think his value should be? So say A is actual true one and S is the result or the test result. So which of these do you think is more important out of all these four values? Which of these things are more important than the other? So basically the first column, the first cell will tell you that you actually have a COVID, and the test result also tells you that you have a COVID. The second one is you do not have COVID, but then the test result tells you that you have a COVID. This is a scenario where you have COVID, but then it doesn't say that you have a COVID. And the last one is you do not have COVID, and then it actually tells you that you do not have COVID. So which of these is should be your main objective when you want to do some rapid tests? So like all of us have gone through corona, so you should have been familiar, like different tests are there. Some of them have higher values of this compared to others. So depending on your objectives, you will be focusing on one or the other. Like ideally you would be requiring this and this value to be very high and this values to be 0 and this values to be 1, but you will not be able to actually get it in practice. So instead you will trade off somewhere in between. So depending on those, you will vary these values lambda 1, lambda 2 and all these values. For the present problem, just to simplify the things, I am just considering like this is 1. It's like I just want to maximize it to the fullest extent, so I'll just take all of them to be equivalent. And lambda 2 is something that I want to minimize, so I'll just write a minus there, minus 1. And lambda 3 I'll just consider is something that I want to minimize too. It's basically true negative is something that I want to minimize, so I'll just put minus. And then the last one is false negatives, which is something that I want to maximize, so I'll just put a plus 1 over there. So is this idea clear? Why am I choosing lambdas to be plus 1 or minus 1? Yes, okay. Now if say in case of COVID or something, if your objective has been to only say these are the ones that you want to minimize, say you want to minimize this, the people who do not have corona, the people who have corona but then that says this as negative. So your only objective has to minimize this particular one. So you want to do some rapid test. All you want to identify is to filter out the ones who have COVID, like this is something that you do not want to have in a rapid test. He has a COVID but then it should, you are fine with the other cases. Say you do not have COVID but then it shows COVID, you are fine with it. But this is something that you are not fine with it. So in rapid test your objective would be to only maximize this. So that would be only your objective. Then what you would be doing is putting all other lambdas to be 0 and only this particular lambda will be minus 1 and remaining everything will be 0, and then solve the problem and then choose your strategy accordingly. So depending on your problem you have to choose which one of them to take. Say if you can pose this in a slightly different way as well. So if you want two of them and one of them is much higher priority than the other, then what you could possibly do is say you can take this value to be 1 or minus 1 and you can take this value to be minus 10 or something and then solve the problem. This has some implications. So instead of solving the original problem, now you have actually changed your problem. So your solution might not be the same as the original one, but in most cases it will work. But it can actually give you different results as well. So it's a bit of trial and error to actually choose which values of lambda to actually that you have to use in your problem. That is something that you call as hyperparameters, if you are already familiar with this term. You call these kind of things as hyperparameters. These are the ones that are not originally involved in your model, but then these are some things that will actually affect the results of your model, like these lambdas that I am choosing here. Okay, now that I have f of xy defined, like this is my objective function. Now I have my objective function and I want to maximize this. What are the values of x and y that will maximize this function? I already know that x and y are probabilities, so there are some constraints on x and y. Both should be 0 to 1. So this is my function. This is something similar that we have solved. So there is the domain 0 to 1. And I want to maximize this particular function x minus y. X minus y is negative slope point. So if you, this keeps on increasing, so this is where you will get your maximum point, and that is or even actually without doing anything you should be able to tell straightforward that If I just take x equal to 1 and y equal to 0, that will be where the maximum value is. Because it has a positive coefficient and negative coefficient, y has to be the minimum value and x has to be the maximum value. Without actually doing anything, you can say that this is the solution. So what is the strategy now? What should be my strategy with this probabilities x equal to 1 and y equal to 0? What does this mean? How does it relate to our original problem? My problem that I started out with is, so if I have seen that his answer is true, what is the probability that I should also mark it as true? I am saying this as 1, which means that if I see that he marked true, I should just mark true, and the otherwise. So if I use this particular strategy, then this particular objective function is maximized, and then using these particular values, I will get the probabilities here. Now if I populate this with these particular values, x equal to 1 and y equal to 0, this table becomes x equal to 1 and y equal to 0. So previously I was having everything to be 0.25. So all are equally likely. But now that I have seen his answer, it has changed into something like this. Now by seeing the answer, the probability previously marking true was a little lower probability, but by seeing this answer, now the probability has increased to 0.3 from 0.25. Is this clear, or are there any questions? I hope there are no questions. So basically the point here is, even after seeing the answer, my probability has only risen up to 0.3. So previously it was 25% and now it is 30%. So should I do it or not? So should I change it or not is again, that's up to you. This is what the model suggests you. Now if you choose a different objective function, if I choose different values of lambda, and then this strategy will change, and then accordingly your probabilities will change. So that is something that you have to do, and that is what you will be doing in your training. You will be varying your model parameters, and then you will get new predictions, and then see which one of them actually suits your needs. Now coming back to the, like here it is straightforward, I have solved it in this way, but now if you want to use gradient descent and solve this problem, how would you go about it? Most of your assignment problems are gradient descent, so how do you solve it using gradient descent? The idea should be clear by now. So or maybe I'll write it in the standard way. So you have some function f of x plus delta x, and then what were you trying to do? We can choose initialization and a loss function. Okay, straightforward. My loss function is this. I have my loss function as 0.4 times x minus y, and what will I choose as my initial value? Say I randomly got some values 0.2 and 0.4. Now say I've chosen a learning rate of say 0.1. I need to ask only two questions now. So first one, what will be your stopping criteria? Second one, how do you incorporate the fact that both x and y need to be 0 to 1? It's like x cannot be any number, it has to be between 0 and 1. Y also cannot be any number, it has to be between 0 and 1. How do you incorporate this information into your gradient descent? Without this information, this particular problem in itself, if you were to do analytically, del f del x is 1 and del f del y is minus 1. Oh sorry, okay, 1 times 0.4, so you have 0.4 and minus 0.4. This will never be 0, so you will never get an optimum point, like you will never get an extremum. Only if you give some limits is when you get an extremum point. And even in those cases, when you give these limits, at the extremum point, this particular slopes will never be 0, but you are calling it as an extremum point because the value cannot go any further below that. So this is different from the one that we have discussed previously. Like when you solve analytical methods, the extremum there is like only when you have del f del x equal to 0, and you know in this case that it will never be 0. So what will be your stopping criteria? How will you know that you have reached the extremum point? Could be number of iterations or loss starts increasing. Number of iterations, okay, now let me put a question. So basically you have suggested two things. One is number of iterations. So if I put number of iterations, will I know that I have reached an extremum? And second, loss starts increasing. Okay, any other suggestions for stopping criteria? So why do you think the loss starts increasing after a certain point? And before actually, okay, say we'll stick with the first one for now, that we fix the number of iterations to be 1000 or so. So once I fix the number of iterations, then I'll do iterating only till that particular point. So that is clear. If you scale the gradients and clamp expert during training. Clamp in the sense, okay. Okay, by clamp do you mean like, so when I'm actually doing the gradient descent, if x exceeds the value of 1 or 0, then I'll actually bring it back to 0 and 1. That's what I think you are referring to. Yeah, so that's what. So if that particular value exceeds the domain that we have specified, then you will actually take the boundary point. So will you be taking boundary points or will you take something else? So how does your clamp work? Say suppose I at some particular iterations I have fixed 1000 iterations, and at say 10th iteration I got x value as say 1.2. So what will I do now? What will I take the value of x for the next iteration? Okay, you will just take it to the boundary 1. So if it is less than 0, then you will just keep it to boundary 0. That could work in most scenarios, but don't you think that by actually forcing everything to 1, you need in this particular scenario you have your extremum at the boundary point, so it should work. I mean it will give you an answer. But say if you have an extremum somewhere not at the boundaries, by doing something like this, what you are forcing is to go close to boundary always. But still it will work in most scenarios, but that is something that you have to think of. I joined just now after the class immediately. Can I get please? Yeah, the recording is always uploaded on YouTube, so you can access the recordings. You will be given the link in your NPTEL course one. Anyway, the sessions are happening, I think 3 times. Like again on Monday there will be another session, another TA will be taking, so you could join that one as well. If this timing is not convenient to you, you can join that session. That email get couple of days later. No, not the email. You can actually access that in the course webpage itself. In the course webpage you can get it. Okay, the link email. The link will be same for every meeting. So the link doesn't change from week to week. Okay, now, okay, there is another comment that, okay, scaling gradients allow x to never grow too large. Yeah, so instead of actually clamping or clipping or clamping, whatever you call it, I call it clipping. So instead of clipping the gradients, you actually have to scale the gradients. So the point is how to scale the gradients, you need to actually have basically change your learning rate. That could be one way of doing it. But then how do you know that like only once you exceed your boundary, you would know that you actually have to decrease your learning rate, right? Before reaching the boundary, you wouldn't know that, right? So how do you know what learning rate to use beforehand itself? That is something that I'll leave you to ponder over. We'll not discuss over that much. But just as I mentioned, like there is another way to actually implement this. just as we discussed, like similar to your Lagrange multipliers, you can put another function here. So like you can change your objective function directly. So you will have x minus y. In addition, you will also add new functions. So say something like, so I already used lambda, so maybe I'll use a different notation. So omega 1 times x square, omega 2 times 1 minus x square, and the other ones. And I'll choose certain values for these omegas. Say maybe I'll choose 1 for all of them. And then if I pose this as my new optimization problem and then solve it using gradient descent, when if it actually found an optimum in those particular scenarios, this entire thing has to be minimized. Basically, this is very similar to your Lagrange multipliers. If it came to x comma y, so if you substitute x equal to 1 and y equal to 0, your f of x comma y will be 0.4 plus omega 1 plus the other one will be 0. Then you will have an omega 4. You will have something like this. So you will have your original objective with whatever constants you have chosen. Basically, your constants should be chosen in such a way that you will enforce this particular problem. This could be another way of solving it, but then this will actually give you some artificial solutions. So instead of 0.4, now you are having something else. So this is the problem that you will face when you have this method is, by the way, this method is called the penalty. It's called a penalty function. So all these parameters are called the penalty factors. So you add all these constraints as constraints with some penalty parameters into your function and change your objective function to something called a penalty function and then solve for the penalty function. So your original problem is not solved. Instead, you are solving a different problem now. So you might get different solution, but eventually your objective is to get x and y. That is something that you will get. But even here, you will still face the same problem that your gradients can actually be quite large and then your solution can go out of bounds. That problem is something that will happen. But if the solution go out of bounds, then this particular error will increase and then force your optimization problem to actually come within the bounds. That is what is expected out of this. Maybe I should have formulated in a much better way. Instead of this square, if I just put 1 minus x, yeah, I should have formulated in a much better way, then it would have been much proper. Okay, so is the idea clear? Yeah, I hope the idea is clear. So that is the last question for this week. So as usual, we have 15 minutes left. So if you have any, so what you could explain what's the use of W1W? Okay. So basically, let's take a simple example. Say it's like very similar to your Lagrange multipliers. So when you have an inequality constraint, so what you are trying to do is as and when you are you do not satisfy the inequality constraint, you want to add it to your penalty function. So say suppose I have this function, a simple function. Let's take a 1D problem. So if you have f of x equal to x square that you want to minimize over the domain x equal to 0 to 1. So what I am saying, now I will add another parameter to it. It's like your Lagrange. So it will take 1 minus x also into account, or say x minus 1. And this particular function will be active only when x is greater than 1. So if x is greater than 1, this particular value kicks in and it will increase the value of f of x. Say if I choose omega 1 of x minus 1 to be x minus 1 if x is greater than 1 and 0 if x is less than 1. If I choose in this particular fashion, then what will happen when you are actually going through your gradient descent, if your x goes a value higher than 1, then this x minus 1 will be added to your objective. So your objective function value will increase, and then in the next iteration, when the gradient descent tries to minimize it, it will try by this additional value will try to push your x inside the domain. Is that clear? Yes. Yeah, so this is the last part of it. Yeah, so if you have any other queries, then we can discuss them. Otherwise, you can feel free to leave the session. So if you have any other doubts, then you can please stay and we can discuss them. I'll keep the forum open. So if you have any doubts, you can just put it in the chat box, or you can unmute yourself and we can discuss.
Durga Prasad, here, as you mentioned, let me introduce myself. I am Ravi, and here, as you mentioned, those links won't be changing. I mean, these session links, whatever
Yes.
we are using. But here, I see that only for week 1 and 2, YouTube links are there. This, I suppose, is week 3 link is not there in the Excel sheet.
Okay, you want the YouTube sessions, right?
Right, the one whichever you gave, right? I got delayed somehow. So this particular session.
Okay, I was referring to the Google Meet session. Okay, if it was a YouTube link, like the session is happening now, right? So it will be uploaded later after the session is recorded. So week 3 will be uploaded today.
And later we would get an email, right?
No, you wouldn't require email. Like it is the same sheet, right? I'll update in the same sheet, so you can access from the same sheet after the session is over.
Okay, so this sheet here, whatever I see week 1 and 2, week 3, one more link.
I'll update in the same sheet, yes.
Okay, yeah, thank you so much.
Yeah. I do not have any lecture notes or something, but for a book you can refer. Yeah, but we wouldn't actually be requiring optimization that we discussed today. But if it was on evolutionary methods or something that other than whatever being discussed in the course, you have separate books for that. So if you want me to suggest one book, which one should we find? No, Christopher Bishop should be fine enough. Like you shouldn't actually be going more that for this particular course. But if you want to study more on optimization, yeah, pattern recognition by Bishop, that should be sufficient for the course. Once neural network comes, then maybe Goodfellow's book, but till then this should be sufficient. Optimization concepts, only optimization related things, if you go into a book, that will be too deep and won't be required for the course. But there are some NPTEL courses, I mean YouTube videos that are available that you can see for this optimization. That will be very straightforward, an easy way to actually do it. If you want to construct your own model, then you might have to know. If you want to use some of the existing models and understand them initially, then you wouldn't be requiring everything that much on optimization. It's like you are in the initial phase, right? So in the initial phase, you should be able to understand the like you wouldn't be requiring optimization that much. That is something that is taken care of by the one who has developed the code. So you should be focusing more on your like how do you develop your model, like getting intuition of how the models work. Optimization is like just to give you simple terms. So if you would have already gone through week 4 lectures, that is where the linear regression is introduced. So ideally you will have 3 steps. So initially you have some data and then you prepare some model. By preparing a model, what I meant is like you parameterize your model. So there will be some unknowns in the model that you need to decide. Say for suppose you have a simple example of a free falling body. The idea here is in a free falling body, you know the equation of motion. You have your equation of motion is straightforward. So you just have one motion, d square y by dt square equal to some constant. So this is my model. all I need to do is find this constant from the data. So how to find, so constructing this model is what is more important in your deep learning things. That is what you should be focusing at least right now. And how to get this value is what optimization takes care of. How to get the value of A from the given data. Even if you do not know anything about optimization, the models, these are already implemented in these packages and you can use them right away. You don't need to know much about them. All you need to know is what optimization does is you have some function that you are trying to minimize, and then it will give you X value out of it. That should be sufficient at least for this course. Yeah. Do you have any other queries? Yeah, sure. Thank you. So yeah, you can feel free to leave if you do not have any questions. So I'll just keep the forum open because the time slot is kind of fixed. So if there is anyone who joins in the last minute to have some query, we can have them. Like, thank you. Thank you all. Thank you. Yeah, I guess then that's it. Then we'll meet next week. Thank you all for joining.